with that, I'll give a quick intro and I'll let Rami speak about his books and whatnot. But if for anybody who's been with the group a little while, you might actually remember Rami. He was with us about 2 years ago. We were discussing a little earlier during setup. Uh, Came to visit and talked about time series, the TS Studio package he works with, and time series and forecasting in general. Um, and has been doing some interesting work around the COVID-19 data project. So he volunteered to come out today via Zoom to talk about that. So with that, I'll turn it over to you, Rami, and let you provide any background you want to provide.
Thank you, Tim. Thank you, everybody joined. Yeah, it's been 2 years since the last meetup. It's happy to be here again remotely, but given the situation, it's the best we can do. I just start to share my screen. So last time we spoke, I presented on the TS Studio. This time I'm going to speak about the COVID-19 R project. Just give you a brief background. The goal of this project is to create standard format for COVID-19 data in R. And I will show an example. But today, the main agenda is to speak about the R data package, and then we'll go to in details to the COVID-19 R project. We show a quick demo about how you can use the data, and then we will have a Q&A.
I forgot to add real quick while we're on the agenda, a quick note for anybody: we are recording, so you are, by being part of the meetup, consenting to being part of the recording.
All right, so before I give you a quick introduction about myself, I think because we're talking about COVID-19 data, it's important to emphasize that I'm not by far any expert to biostatistics, epidemiology, or any disease. I'm mainly focused on the data side, and I'm not focusing on the modeling part or predicting the cases, confirmed cases or death cases, but only focusing on the data. I leave the expert to do their job on this side. And this is who I am. I'm a data scientist. I love R. I'm mainly focusing on time series analysis. I wrote a book which was released about a year ago, hands-on time series analysis with R, which focus on time series analysis. And I am author of several packages, such as the TS Studio, which I presented last time, Forecast LM, which is also focusing on linear models for forecasting time series. And recently I started to work on the COVID-19 data. So with that, let's just quickly introduce the concept of the R data package. I'm sure that because it's R group, most of you know, or if not, you probably use without knowing. R is probably one of the unique programming language that hosts data in libraries. And the main idea is to help to communicate the functionality of the package in some cases, or to provide some examples, or to enable to explore different type of data for educational cases. So if you think about it, one of the most familiar data set is the diamond from the ggplot, which they used as example of how to use the ggplot package. And there is the iris data set that is part of the data package from base R, which mainly used for educational purpose, for machine learning examples, classification, or clustering. And there are other examples. And the main advantage of the R package that it's easy to create, it's accessible, and it keeps the data attributes. So once you save the data as a package, it will stay in the same format that you save it. Unlike usually when you see in other languages examples that you're loading a CSV file to show some example, and then you need to reformat. If you already reformat the data before you save the data, it's there and it will stay in the same format. And it's really convenient when you work with dates or different classes that you want just to keep it as it is and not deal with the reformatting. The downside of it that once you push it to CRAN, it stays there and it's very hard to update. CRAN don't like that you push frequent updates. So if you want to maintain data package, typically like you need to maintain like intervals of 1 month for the updates or more. And there is the size limitation that is the size of the package cannot exceed 5 megabytes once installed. So obviously you cannot package a huge data set like the New York taxi data, the full data, which is kind of like a giga of data set. But for small cases and in 5 megabytes, you can actually have a huge CSV file. So it's useful. It's not replacing API or any other type of database that we use. And this is typical workflow when you create a data package. And here the examples is, I gave the example of 3 data packages that I created. The coronavirus, I started as a project on February that packaged the data from Johns Hopkins. The US grid is the electricity demand and supply in the US, and the UK grid is the equivalent in the UK. And in order to package a data, you need a data source. So it could be a GitHub repo, it could be API like the US grid, or flat files like the UK grid. And then you need a script that take the raw data and reformat it if you need it, and save it as RDA dataset. Or in some more, if you have your data is more, if you're working with APIs or more complex structure of data, I typically use Bash to run a reformatting of data and pulling from APIs, but there's nothing you cannot do in R. And then there are some utility tools that make your life easy when you are packaging it. Is they use this, they test it, and obviously I forgot to add the DevTool package. Last and not least is something I discovered while working on the coronavirus package is the automation part with the GitHub Action. There are other tools, but I use GitHub Action that enable you to set cron jobs and automation. And I recommend if anyone using GitHub to explore this tool. It's really cool. So what is different in the case of the COVID-19 data packages? And this is on the right side, there is a link for repo with the different packages that are focusing on COVID-19 data that Dr. Miné Rondel created. And the main thing that I think this is the first time that we are tracking an ongoing event, meaning this is happening on a daily basis. There is new data and people want to get the most recent data. The second thing, there is uncertainty. The data keep changing. On February, when Johns Hopkins published their initial data set, it kept change until it got into some maturity after a month or 2 months. And if you rely on external data sets, you may need to modify your code based on those changes that typically you're not aware that they're going to happen until they happened. Also, there is data errors. You could pull data for the US from different sources. Not necessarily it's errors, but discrepancy. And the numbers will be different because maybe there are different counting methods. So if you pull from Johns Hopkins, you might get for Ohio one number. And if you pull it from the New York Times data set, you may get different number. And this is related to the way that the resource are counting the cases. And the data need to get updated on daily basis, which is not really doable when you're working with a data package. So just to give you brief about like the amount of effort I spent on with the coronavirus. So this is the shared area is my commits before I started to work on the COVID-19 data, and this is moving forward. The data kept changing on daily basis, and I had to spend overnights to update the changes and reformat the data. So before we jump to the COVID-19 project, give you some brief introduction on how the project started. And I was going and looking for the event because I usually publish it on Twitter, and I thought like this would be a nice way to present it. So on early February, this is where the point that they started to have some interest about the coronavirus. And at that time, they call it coronavirus. And I was looking for who have the data. And the next day, I found the repo of Johns Hopkins. And 4 days after, I was publishing the package on GitHub. And then 10 days after, it was already in CRAN. Then I think at the beginning of March, this is where all the data issues started, as Johns Hopkins keep change the resources they used and the fields. So I had to keep iterating on the structures and more issue came with the data. And I think somewhere in the end of March, I got 2 pull requests from Gerard and Amanda about how to collaborate with create new features for the COVID-19 data. From the pull request from Amanda was to incorporate US data that she pulled from the COVID-19 tracker. And Gerard sent a pull request about creating visualization on maps. And when we started to work together, we realized that we are talking in different languages in terms of the structure of the data. And each one is using a different structure. And in order to bring the coronavirus in to the point that we can merge those data sets, we will have to do a lot of reformatting and adjustment. So we said, why don't we just create some kind of like standard? What should the data look like? And this is how we started to work on the COVID-19 R project. And the whole goal of this project is to create a uniform standard for data for people that are packaging COVID-19 related data in R. And somewhere on May, we released the project, and now it's available on GitHub. So what is the COVID-19 project? So it's provide, and I think it's like the main message from this meetup that I want you to take, is that it's to provide a tidy and uniform data format. So no matter if you go and pull data for Canada, France, Switzerland, or any country, you always will get the same type of data structure. You will have the first column is the date, then the second column is the location. The third column will define what is the location type. So in this case, we see the New York Times data set. and the location type in this case is state, and then the location code. And the code enable you to merge the dataset with some geospatial data that enable you to visualize it. And there is other fields like the type of the data, like new case, total case, and I will show the vocabulary that we are using. So again, if you see like the location code, this enable you to really fast merge it with geospatial tools and create visualization. We created a documentation that enable anyone that want to contribute to this project to go and build its own package. And the idea is to give the maximum tools for people that never develop package to start develop their own package. So the documentation is go step by step. What do you need to have in your package in order to follow the format and the tools that are required? So for example, is what do you need to submit it to CRAN? What are the checks? What are the unit tests that you need to have on your data? What is the standard format? And the bottom line is that when the user pull the data, it's ready to use, it's easy to access. It's updated on a daily basis, and I will show the mechanism of it in a second. And just enable you to keep the data as with the most recent data that's available on the resource that you are pulling the data from. Also, the idea is to create a contribution community. This is open source, and we are welcome anyone that want to join us and build COVID-19 dataset package to join us. I think it's important cause to do on those days. And we have all the tools to start. So if anyone is interested, so ping me after the meetup and I can guide you how to start. So we have more information. I will go over it on the demo about the resources that are available on the repo from the documentation and about the packages that are available. So far, those are the packages that are available on the project, each on a different stage. Not all are CRAN ready, but we are working and adding more features and adding more data sets. So the first two packages are controlling the rest of the data set that's available. And the idea for the COVID-19R and the COVID-19R data that they work as an API. So if you don't need to install, for example, the COVID-19 New York Times to get the New York Times. If you have the COVID-19R, you can just install it and pull the data from there directly. And it's kind of like generalized. Once someone contributes a package, it enters to this format and it's used as an API. And then there is the New York Times. There is cases in France, in Canada, in Switzerland, Italy. The mobility is the recent data that Apple released. And I think that I missed, there is also cases in Virginia State. One thing before we'll go to the demo is what I mentioned in the beginning is the GitHub Action tool. And this is what keeps the data refresh on a daily basis. So the structure of the package is it's not hosting the data on the package itself, but it's used as a scripter. It's scripting the data from the resource. So for example, if I'm pulling data from the Johns Hopkins dataset or from the New York Times, the function is just going and script the data from the New York Times repo, and that's how you get the most recent data to your hard drive or working environment. And by using the GitHub Action, it enables us to create a continuous integration, and it's really awesome tool. And I recommend if anyone developing package to check this tool. I only started to use it recently. Last but not least, this is still a work in progress. We just started about, it seems like a long time ago, but it's like 2 months ago we started to work on this project, and we just finished to create like the structure, but there's still more to do. I think that our end goal is to create, beside the infrastructure to create packages, also to create the supporting tools. And this is where the structure of the data will be useful when any person that want to use the data can use it with the tools, with the visualization tools, no matter what is the source, because it all will be in a tidy in the same format. So let's just go to see some kind of examples. So we start with the repo. This is the COVID-19R. This is the project repo. And here there are links for some resources. So the first is the documentation available here. There is the COVID-19R package that provide access to all the data set that available on the project. So the idea is that there are two functions. One is the get COVID-19 data info, and you can get all the data that's available on this project. And then the second thing is you can, let's say that you want the COVID-19 France. So you can actually go and use the get COVID-19 dataset and specify the dataset that you want to pull, and pull the data without the need to install that package. So this is kind of API. It's not API because I would say it's a primitive format of API, but it works as API. And then there is, this is the project documentation that enable you to build with instruction about how to build a package. So it started with how to start with the new package, how to write a vignette, set a unit test, and what are the requirements to submit, like the checklist to submit to Crane. One thing that I mentioned before is the data structure, and this is, I think, what makes this project unique, is that the standard that we created to the data, that is uniform across all the data sets. So no matter which data set you will pull, you will see the same structure. And we set a vocabulary. So if you go and you see there is the location code type or the data type, we set on the vocabulary chapter all the corresponding types of variables that could appear in the data set. So for example, and this is relevant for geospatial visualization, there are different codes that are available on different data packages. So if you're using the R Natural Earth package or the SF package to visualize map, you want to pull the geometric data of your data sets, and you want to use the codes that are available here. So there are different codes, and we are adding, if there will be need in the future to update it, we will update it and add. There are infinite number of codes. And those are the types of data type. So it could be new cases, total cases, recover, total, recover, new, and so on. And the idea here is to create a clear vocabulary about what format the data field is. So before we jump to the example, this issue on the COVID-19R are example of different data sources that are waiting for someone to come and start to package them. So if anyone want to start and want to look for interesting data sets, I would recommend to go to that issue number 1 in the COVID-19 R package. And there are tons of data sets. So there is Uruguay, Slovenia, Estonia, Japan, and so on. There is more data than we can actually package, unfortunately. And this is an example I created to demonstrate how to use the package. In this case, I will use the COVID-19 New York Times package, and I will show how to load the data, to refresh it, and to visualize it. So we will use a dplyr and tidyr to reformat the data, to merge it with the geospatial data. We use the SF package for the geometric data. The Tigris package for the census data of the US, and the map view for visualize to create the map. The map view is a wrapper for leaflet JavaScript package. So the first thing that we will do is to use, after we load the package, is to refresh the COVID-19 New York Times data. There are 2 types of data sets available in this package, is the counties and the states. In this case, we will pull the counties. And as you see, unlike normal data that you load in our package, we are not using the data function, but we are using a specific function that is going to the resource and doing the scripting, live scripting, to pull the data for you. So you see that I ran it a couple of minutes ago, and the data is updated until, I think it's yesterday, the most recent data that's available there. And it contains the same structure: date, location. Location code is the FIPS, which I think is equivalent to the zip code in the US, and it's unique for the US. And there are 2 types on the county. There is total cases, the aggregate level, and of confirmed cases, and the death cases. And the last column is the value. So we start with a simple summary statistic. If you take these data sets and you're interested to know based on May 14, and actually we can change it to yesterday. To get the most recent. So what I'm doing here, I'm filtering the data because it's already aggregated. I'm filtering to the most recent date. And then I'm selecting the location, which is, in this case, is the county, the type of case, and the value. I'm reformatting it I'm moving it to a wider format with the tidyr package. Let's see. And I'm calculated the death rate based on those 2 columns. So, and eventually, and I sorted by the number of confirmed cases. So eventually, I'm getting a table of 4 columns. The first column is the location, is the county. The second column is the total number of cases. Then the third column is the death. And then this is like the death divided by cases, which give you the death rate. One thing to mention that in some cases, the county level is not available. So for New York City, you don't see the county, you see the New York City as total. But for the rest in this list, this is the county, and you can see that after New York there is Illinois. This district is probably one of the major. Los Angeles is after, and so on. One thing interesting to see, and that the death rate is different from county to county, and in some cases it's fairly high. And maybe this is interesting topic to research if someone get the data about the characteristic of the population. I could guess that it's related to age, because we know that the COVID-19 is more deadly for older people, and I could assume that this is related to the age of the population, the distribution of the age, but there's something that at this point we don't have the supporting data to test this hypothesis. The next thing I want to show is how to create a color plate maps based on the county. So we start with the overall map of the US, and then we will go to the lower 48, and it's not going to be Minnesota, it's going to be Ohio. So we'll start with, and this is what's great about, I think, about this package, that once you have the code, it's easy to merge it with the corresponding geometric data. We'll take the refresh data that we pulled for the 25th, and we only use we're going to visualize only the confirmed cases, the aggregate level. So we'll start with left join the confirmed cases with the county map, and I think the county map is not showing here. Yeah, it's not included. So before I'm merging, I'm pulling the county geometric data. So for this, I'm using the SF package. And using the counties, it's giving me just all the required data to plot the maps. Once I merged, I did a left join with the county maps and the data frame with the data itself. It is straightforward to with the map view to plot the data, and here we're getting the all US, including the states and territories. Since there are some territories somewhere in the Pacific, we're getting a large view, but you can zoom in and focus on the mainland and get this view. So it may be more interesting to visualize the US, so I will only the 48 states. So I will filter Alaska and Hawaii and the territories, and we'll create a new data frame that is only including the lower 48 states. So you can see I'm using the map view. You can set the value of the colors, like the buckets, based on the number of cases. And here I'm setting it up to the max number of cases. So that's how you create the scales. You see that for some counties, the data is missing, and this is missing on the raw data. But for the majority of the US, the county level is available. And since we are in a meetup in Ohio, I thought it would be interesting to show the cases in Ohio. So based on, I think this is from the 25th. I think that this is Columbus, is the highest number of cases with 5,300 cases. I know how is, I guess this is Cleveland, fairly high with close to 4,000 cases. And of course, you can see that as you're going far away from the major population area, the color scale is changing and the number of cases dropping.
The hotspot there is Marion, Ohio. It's a prison. It's
Over
not.
here?
It's not because of Columbus. It's because it's a prison with a huge number of cases.
Yeah. So this is the same case in Santa Clara. There is one prison that there is 1,000 cases, which is insane. But generally, like I think it makes sense that like you will see that the color is more on the, like you can see like where are the population. Maybe this is outlier, but like if you see overall in the US, not here, and this one, that's as you go more to the rural, the number are dropping. So with that, just want to mention the people that are working on this project. So Amanda and Jared, we started this project, and then Morgan joined us recently. He contributed the COVID-19 for Canada, and recently, I think yesterday I saw it on the project for Vermont. And we are welcome anyone that want to build his own COVID-19 package to join us. This is open source project. Anyone is welcome to join. With that, if there is any question, we'll be happy to answer.
So I'll ask a question. This is very nice, but I have a question about your use of, I've never seen the map view package before, and it looks very similar to the leaflet package. Can you comment on those? Do you know anything about those two packages?
Yeah.
And their differences?
So in R, there are a few wrappers for the leaflet, JavaScript. There is I think RStudio provide one version. If I'm not mistaken, it's called Leaflet R. There is another thing called Leaflet without the R. And MapView is another wrapper. And I know there is at least 4 wrappers. They all use the JavaScript. I like the MapView because it's, as you can see, it's really straightforward. You need to have the data frame with the geospatial data, and you need to specify which column you want to plot, and that's it. So they have a really nice vignette. I never used maps until I started to work on the COVID-19, not in that scale. So something that I learned in the last 2 months. But they have a nice documentation and vignettes step by step how to start with mapping. There are different features, how to set colors, backgrounds, and so on.
So I think I'm mistaken, actually. I was just looking at a map. I guess Marion is not, it is Columbus that is that hotspot. Sorry about that. Marion is the one above it. It's a little bit less. That green one just north of Columbus. So Columbus is that. I thought Marion was our hotspot. Yeah. That's the prison. Not. So Columbus is very bad. Yikes.
Well, it's probably really bad per capita, right? This is doing total cases. That's why Columbus is so high. Per capita, Marion County having that jail probably has a ton per capita.
Oh, right. Yeah, sorry. Yeah. This is not normalized by population. Yeah, so yeah, that would make sense. All the population is in Columbus. Yeah.
Yeah, so I think if you are interested to normalize, I think the the Tigris package provide this information. You can pull it from this package. I think you have like this is census data. So I believe that you can get all the information on any county in the US.
So I'll go next. So you're talking about how, CRAN, the limitation is you can't update as often as you want. Have you thought about setting up your own, like sort of mini CRAN or DRAT or one of these packages to have your own sort of server so that you could update it? You could have your CI upload the package every day, right? And then you wouldn't have to worry about limitations like that.
So the way that we solve it is by setting these packages. And I think this is a discussion that we still have about how, so the function that pull the data, I think this is the COVID, yeah. So you see this package hosts the raw data. So every day it's going and scrapping the data. But the thing that we are not pointing for the data over here. And this is internal discussion that we have. If maybe instead of pointing to the, let's say to the John Hopkins or the New York Times repo, let this package do the cleaning, and the package itself will pull it from here. Because the main problem, once you push it to CRAN, and you have some structure that you're cleaning the data, if the raw data is changing, then you need to push update to CRAN. And this is kind of like taking that sometimes. So I can show an example in the COVID. So some of the packages here are still not using the format, and the idea is to move all of them to the format. So COVID, the coronavirus is like, I think the first R package that was around the COVID-19. And I still, I didn't want to change the format because I think like people start to use it, and changing now it would be kind of like annoying to some people. But I have a function that refresh the data. So what it does, I'm scripting on a daily basis. I have here a cron job to see the action. And it's running this simple script that is basically after it's installed, it's running this file data refresh, pull the data, clean it, and reformat it, and save it on the package. So once you install the CRAN version, you can refresh the data by using, I think I have it somewhere here. No, it's, sorry, this is not update.
So that's how it works. So if you install the CRAN version and you update, does it overwrite itself somehow, or?
It's
Okay.
overwrite it. Yeah. So you have this function, and what it does, it's check what installed on your machine and compare it with the CSV that's available over here that
Gotcha.
get updated on a daily basis. So you see the last push was 19 hours ago. It's refresh the data over here, save CSV, and save it as a data set on the data folder.
Got it.
So once you install the CRAN, you just need to do the update dataset, and as long as the data is not changing, even if the data is changing, I can change the script that refresh the data. It's not part of the package.
Mm-hmm.
The script that refresh the data is here, and it's not pushed to CRAN. So I need to change only the GitHub version without the need to push to CRAN. So this is kind of like the middle solution.
Yeah. Is there any concern about, because I know the GitHub limits like I think 100 megabytes for a file. Are you anywhere close? I don't know how big these files are getting, but
No, I don't think that we are still. I think that the biggest one is 50 megabyte.
okay. So you have some wiggle room.
Yeah. And when we talked about like in the future, if we will, it's get developed and we get more support, we will maybe go to AWS or something like this. But I think we still don't have, we didn't get to this point that we need to go to this type of solution.
Thanks.
Hey, Rami, Paul Newton here. Hey, terrific job with everything you've done. It's nice to see. I've been using it a bit, but can you talk about some really nice things that you've seen people use your data for?
Yeah. I think one of the things that I'm mainly proud of is the reproducibility. When I just started to work on the coronavirus package, I created a dashboard. And so I'm not refreshing it now, but this just provide a summary of the number of cases and provide map, trends, and so on. And I create this tab that give all the instruction about how to reproduce it. And what people start to do is create their own dashboard. So I think there were like 20 different dashboards that people created based on this dashboard. Either take this dashboard and create their own version, or just to create it to create a version for different states. I know there are other folks from I think South Dakota University that took this data and create a Shiny app, and I know there are also several Shiny apps that running using this data sets.
That's terrific. Thank you. Yeah.
You're welcome. And I can show you another. So there's the COVID-19 Italy, and this is a different R Markdown version that I just use it for Italy. So it's summarize the number of cases in Italy, providing a different view on the Italy regions or the overall view, and use the similar format. This is one of the things that I discovered during while I started to play, that you can actually deploy Flex dashboard on GitHub pages, because it's eventually it's R Markdown. So it is really straightforward. And if anyone interested, there is over instruction about how to do it. I use this repo with instruction about how to deploy any R Markdown on GitHub pages.
Oh, that
really
is
cool.
useful. Yeah.
It's really straightforward to do it. So I can share these links after the meetup if anyone want to play with GitHub pages.
It's a Flex dashboard. It's not based on Shiny then?
Yeah.
I thought it was.
Yeah, so this is deployed on my GitHub page. So basically, where is the?
Okay, so you can't like select things in this dashboard. You can.
No.
You can use, yeah. Okay.
No, it's a static. It's a completely R Markdown file. When you if you I cannot see the setting, but like once you go to the setting, you can set as once you create a docs, there is a format that GitHub. If you follow this format, you can create a page. You need to have a docs folder and index. Once you create your R Markdown as index.html, that's it, and you put it on docs. you have a option to set it as page, and it will render it and run it. And this is our block down, or all the book down, block down, all the markdown format are working that you see deployed on GitHub pages. This is
Yeah, I was surprised. I thought Next Dashboard was based on Shiny. That's
well, you can use Shiny. You can incorporate Shiny, but
I see.
on the base of it, it's a simple R markdown.
I see. Okay, thanks.
You can create it interactive in the sense of dynamic with any of the feature of Shiny.
I guess I'm curious, do you feel in your experience there's more issues with, the discussion in the news, right, about standardizing what is a coronavirus death, what is not a coronavirus death, those type of things. So there's debate within the domain. Obviously, there's on the cases, there's a complete, testing obviously is a lot of an issue. I know folks here in the area that feel they've had it, but never had a test in the window. So they're not, certainly not counted in the cases. Are you seeing more issues like that? Or are you seeing more technical issues of like you had the counties that just completely aren't tracking whatsoever?
I think it's a combination of both. I remember like when it just started in the US about, I think it's like, it feels like it's years here, but it's like, if you think about it, like 2 months ago, it's really out of the US, like somewhere in March. I was looking for data that's available, one place that provide information about the whole US, and you cannot find one because each state has its own health department that provide different numbers. So it could be that like one state really provide good API with information and detailed information, and other states won't provide anything, just some summary. So it's one of the, at least it was the joke that I made with some of my colleagues that if you look at the World Organization or the one in Europe, I forgot the name, like the European, the equivalent to the CDC, that I hope they're handling the epidemic better than they're handling the data. They don't provide any API. At least at the beginning, all the data came by scripting their PDF reports that they provided on a daily basis or flat files. So one of the things that maybe will trigger after we finish to handle this event is like, are we providing more accessibility for data? And there is also if you will check 2 resources, you might see different numbers. And this is because one could be that one hospital count in one way and other hospital count in a different way. And there's an argument about this, but we're trying, I think that we, at least on my side, try to avoid those arguments we're just providing the pipeline for the data. We are not scripting the data unless there is a resource is reliable. And I think this is what we leave this to struggle, like the struggle about the data to John Hopkins or New York Times, that are doing a great job providing this data. But probably it will never be one-to-one.
Yep. Yeah, I think that's very illustrative of just, you see that in Kaggle.com problem forums and those kind of things. People just coming in with the idea that the data is the data and it's correct, and not understanding, 2 experts can look at the same thing and see different things.
Yeah, and one of the things that I got a lot of issues because for the coronavirus package, because I'm taking so Johns Hopkins provide aggregate data, and I just took the diff to get the daily. So I'm subtracting what is today with yesterday to take like how much the new cases. And sometimes you see there are negative values. And people ask me how it's possible. And when you go to the raw data, you see like that there is decrease. And the reason that if once they found that they are finding errors on the data, or maybe because it could be like a false positive that are removing those cases, they are not remove those cases on the day that they were added. They're removing on the day they discover that they have a false positive. And this causes that sometimes the data probably not represent a specific day. Maybe on the aggregate level, it represents what was the actuals, but if you want to look at the daily, it may not represent the day that you are looking at.
There is a famous comment from Dr. Deming, and he says, there is no such thing as truth in this world. It's only an estimate.
Probably, yeah, you can. I mean, this is the clause that we have about understand the data, like understand the epidemic. But there are so many parameters. If you think about worldwide, when Johns Hopkins pulling the data, they are relying on each country that provide the data, and not all the countries are maybe provide the two cases, or maybe some countries they have a delay about until they're providing the data. I'm looking at data from Israel, for example, and there is a 1 week delay until they release the actual cases. At least for the public, like the data for the media is available the same day, but like the API that's available is in a few days delay. So,
same thing is true with New York State, even though they are doing a bang-up job. There are data that are reported cases which are and deaths which are based on hospital data, and then there are people who had coronavirus, never went to the hospital, died at home, and the autopsy discovered that it was coronavirus. So even in New York State, there is a mismatch of data, and that's why all these experts are saying that the actual number of deaths is probably considerably higher.
yeah, I think that like the main thing that we need probably to take from this event is that the health department probably need to improve the way that they are collecting the data.
No, it cannot be done. It's impossible. The real data are available, if you will, properly sanitized, tested, validated 18 months after the research project is over.
Yeah.
You know, the complexity of the actual data collection as well as the size of the data set makes everything really messy. And then politics comes into play, and it says, you know, I want to add up all this data together so you don't know what's going on.
Always there will be politics, but
okay.
Yeah. But I think our job is just, I mean, we are trying to provide the data accessible for those resources. And you should always caveat that there might be some discrepancy in the data because of those reasons.
Hey, Rami, I'm really interested in the GitHub Actions. Is that spinning up a container of sorts to run all that, all the scripts you have there? Or what's going on behind the scenes?
So can jump to example. Yeah, it's spinning some machine. Let's take this one. So actually, maybe show the code. So you set, when you set the GitHub Actions, open this folder with the workflows. And like one thing that I'm using is testing. So if you see the build badge, this is representing once you push any commit, it's running the RCMD checks. So you need to spin a machine, install all the requirements. So you see it's very simple, simple code. It's a YAML file that you set when you want to trigger it. So in this case, I'm triggering it. Let me make it bigger. On pull and pull request, on push and pull request. And then this is the job. So you set what machine you want to run it. You can either Mac OS, Linux box, or Windows. And then you set the steps. So in this case, first I'm checking out I'm pulling the master branch. I'm installing R. So this is the installation of R. I installed the requirement packages that I need to run the checks. So it's the remote and RCMD check, RCPP. And then I'm installing the dependency of the package. And the last step is to run the RCMD check. So this is, let me see if I have example, how does it look? So each time that it's running or triggered, let's see the build. It's triggered those steps. So you see this will install, I cannot open it, but actually, so you see, let me make it bigger. This is just go and install the R. So those are what is running on the machine. The reason that I'm using, setting it as a Mac system is because it's easy for me to install with the brew, all the requirement. But you can do it with any other Linux or Windows, doesn't really matter. Just need to use the tools for the other OS. This is running the R script. I'm installing the dependency. And then once all the dependencies are there, I can run the check. So it's literally like if you run on your machine, I don't have it here, but like you should have like the build. So it's running the build and it's triggered the RCMD build. We make sure that all the checks are passed. And if you have unit tests, and this is where it's become very useful when you have unit tests, it's run those unit tests. And if they're not failing, so you get it's passed.
Okay, great, thanks. So the steps, run, actions, checkout, and RLib action setup are, is that something that GitHub has automatically, or is that something you wrote to set up, like install R and it'll do all that stuff?
Yeah, so you go and if you want to, you just create a new workflow. And you can either create a set, there are already built-in set of tools that are already available. So if you work with, I don't know, AWS, you already set of workflow for AWS, for Kubernetes, or any other devices. There is a good talk, actions.
Yeah, it's too bad
There is
Jim's not
this-
here.
Yeah. So Jim has a talk that I'm actually that's what I'm trying to look. Jim has a talk about it. When I started to learn, I actually went to his repo and get all the examples, and he had a talk on one of the. I don't think it's either the most recent one or last year RStudio conference.
Great. Yeah, I'll look for it.
Yeah, it should be somewhere. Yeah.
Awesome. Thank you.
Yeah, so this is probably you want to look at this, and he has examples on his repo. Let's see if there is link for the.
Yeah, I already added it to the chat, the one. Basically, GitHub makes it so that you can point to any scripts on a GitHub repository and they'll run. So Jim
Got it.
has one to install R, so you just point to rlibs actions, set up R on the master branch, and that's going to run Jim's
Oh,
script.
okay.
So-
So that
Yeah. And so if anything breaks, Jim will fix it, and then you don't have to change your config file, right?
got it. So that's a different repository that's being called there.
Yeah, and so
Yeah. One thing that I recommend if you start to work with GitHub Action, create a Docker image, and instead of this is something that it's in my to-do list, instead of installing it manually each time, create a Docker, because like in 2 days on Friday, it's going to be a push of dplyr. And typically when there is, if you're using dplyr, for example, in this case, when a package push to CRAN, there is two versions of the package. There is a source and the binary. I forgot which one, but one is laid down on the day that the package was pushed, and the other one get updated a few days after. Typically when you try to install it with DevTools or any methods, it will see there is a new version, let's say dplyr 1 on Friday, but either the binary or the source, I don't remember which one, is not available, but it will try to find this source and it will fail. So once you set a Docker image, you're set. Unless you want to add new features, you're good to go.
Thank you very much, Rami. We appreciate you coming by and doing this.
You're welcome. It was really my pleasure to come again.